All right. Good evening, ladies and gentlemen. Let's see how many people we have so far. We have 0 so far, but I will just wait for a little bit. And yeah, it's a surprise live stream. All right. And today, what we are gonna do is we are trying to see if this series converges or not. By the way, thank you guys so much for 100,000 subscribers on this channel. I really appreciate that. And yeah, so that's what we will do today. We are going to see if this series converges or not, and once we solve it, we'll be done. Alright, so we have the series as n goes from 1 to infinity of 1 minus cosine of 1 over n. And I have my phone in front of me, so if you guys drop any comments or any messages, I can read your chat. Hello everybody, thank you guys so much for coming. Right now we have 25 of you guys. And for the people who just come here, thank you guys so much for the 100,000 subscribers on this channel. So it's like a surprising live stream. I was going to record the video on this, but like, why not do a live stream, right? But let's see if this is converges or diverges. Thank you. Alright, thank you guys so much for the nice comments. Hello everybody. So the goal is to see if this right here converges or not. We have the series as n goes from 1 to infinity of 1 minus cosine of 1 over n. So just kind of drawing some ideas, right? So again, this live stream will end when we solve this, right? And just somebody tells me how to do it, and then I will write down the solution on the board for you guys. TFD, so let's go ahead and try that first. TFD means that we are trying to do the test for divergence. So we will have to check the limit as n goes to infinity of this expression, 1 minus cosine of 1 over n. But if n goes to infinity, we have 1 over infinity, which is 0, right? So this is 1 over infinity like this. And 1 minus cosine of 0, this right here approaches 1. So we end up with 1 minus 1, and we get 0. And when we are trying to do the test for divergence, if we get 0, unfortunately, does not do us any good. We cannot draw any conclusion. So no, this 0 is a sad face. So no test for divergence. Alright, just drawing some ideas. Of course, it's a 50-50 chance, right? Either it converges or diverges, but why? What's the convergence test that we have to use? Oh, cool. Same hoodie, same Berkeley hoodie. Cool. I have this for such a long time. 10 years? I don't remember. 8-10 years? Yeah. The conditions for test for divergence is you check the limit as n goes to infinity. If this right here doesn't give you 0, then you can say diverges. Oh, let's keep in Cal 2 methods. So we don't do the I don't know how to pronounce that properly. Yeah, we don't do that method because, and plus we don't really go over that in Cal 2. Okay, so again, let's see who can help us out with this one. Because if nobody solves it, I will just keep live streaming. I don't know. Alright, so I have another suggestion. Wow, a lot of chat. Let me see. Alright, so we are going to compare with 1 over n. Let's try it. So what comparison would you like to do though? We can do a limit or we can do the direct comparison. So which one? And then we can try the integral test next. So again, if you want to use comparison, what kind of comparison? What kind of comparison test? We can do the limit or we can do the direct. Which one would you like to try? I think it was Martin earlier. So limit comparison test. Okay, let's try it. Let's try it. All right, if you want to do a limit comparison test, you have to tell me a series that you want to use though. Limit comparison test with what series? One over n squared? I don't see n squared though. Why? I don't see n 1 over n squared. So what made you say that 1 over n squared? 1 over n cube? I don't see 1 over n cube either. 1 over n? Let's try that. Yeah, let's try that. Because we have the 1 over n, so let's try this. Yeah? Okay, if you take a look right here, this is just the p series when p is equal to 1, which is less than or equal to 1. So what's the conclusion of this series? Converges or diverges? Oh, wow, we're 100 people now. Yes. 100 of you guys, thank you so much. This right here diverges. It's a harmonic series. Yep. Now, check this out. Right? Check this out. If we want to do the limit comparison test, we are going to check the limit as n goes to infinity. And let's put down the one that we're trying to figure out on the top. And then over the one that we know on the bottom. For this version of the limit comparison test, we want to compute the limit and hope that we get a positive finite value. And if it's a finite number, then we can say that they both have the same conclusion. This diverges, so we can also conclude that that diverges. But let's see. Keep in mind though, when we do the limit comparison test, this limit should be a positive finite value, right? So not infinity, no zero either. No zero either. All right? So let's see. Take the limit as n goes to infinity. The top is 0. The bottom is also 0. So let's do the L'Hopital's rule, yeah? Okay, let's do L'Hopital's rule. So I'm just going to differentiate this. This is a bad notation. I'm going to change this to x's. Because if I want to use L'Hopital's rule, I really don't like it when people say ddn. So ddx, right? ddx. Anyway though, if you do all this, take the derivative, this is L'Hopital's rule, we have 0 over 0 case, yeah? Okay, so we have the limit as x approaching infinity. Okay, that's a horrible infinity, I know. The bottom, we get negative 1 over x squared. The top, the derivative of 1 is 0. The derivative of negative cosine is positive sine. The input stays. And then use the chain rule multiplied by the derivative of that. And as you can see, this and that cancel exactly. But if you have the x approaching infinity, 1 over infinity is 0. Sine of 0, we get 0. So this is another sad face. For this right here, 0 does not help us draw any conclusion when we do the limit comparison test. Try integral test. I'm just going to put down the integral that we will have to evaluate. Remember, in order for us to use the integral test, perhaps the most important thing is, can we integrate the corresponding function? In this case, it's 1 minus cosine of 1 over x. And let's say we go from 1 to infinity. Can we do this nicely? I think the most important thing that we should consider is, can we integrate this? Of course, later on we have to check if the function is positive, decreasing, and continuous. But if you cannot even integrate this nicely, I think it's like, not so much either. All right. I think, Samir, you said limit comparison test with 1 over n squared. How come? How come? What made you say 1 over n squared? By the way, I can read your chat. My phone is right in front of me, so I can read the messages that you guys are saying right now. You want the Pokeball. You want the Pokeball. Where's my Pokeball? Just for you guys, alright? For the 107 of you guys, you want the Pokeball? I will give you the Pokeball. Just give me 1 second. Actually, I don't know where the Pokeball is. Oh, hey, I got it. Guys ready? Here's the Pokeball. It's really dirty now. So yeah, it's still here. It's still here. Who asked for the Pokeball earlier? Let's see. Nox. NOX. Yeah. So how I say that right? Yeah. This is the Pokeball for you guys. Yeah. Anyway, though, here, I think I saw the correct answer earlier. So let's do it. Alright. So there's a suggestion. It says I would say 1 minus cosine of 1 over x is equal to 1 minus x squared over 2 plus O of x. Oh, the little O notation. Yes, you can do that. We don't have that in Cal 2 though, so I'm going to keep it with the Cal 2 methods and the notations. Oh, cool. Oh, you and I will have the same birthday, July 15th. That's really cool. So, if you want to integrate this, not so much. And then the limit comparison test, we end up with 0 for this right here. Not so much. Right, so I'm going to erase this now, and then I will just see if we have more suggestions. And let's see how long this will take. Right now, it's about 12 minutes. We'll live stream until we solve it. Oh, hey, Arash, we have a very nice suggestion. Use the trig identity. Sine squared of theta over 2 equals 1 minus cosine of 1 over x. Aha, let's try that. So perhaps I'll write down the identity for you guys on the side right here. Note that this right here is just pretty much the power reduction formula, and you look at it backwards. If you look at sine squared theta, this right here is actually equal to 1/2 times 1 minus cosine of 2 theta. Can we still see this? Oh yeah, cool. Yeah. And also you can see we have 1 minus cosine, 1 minus cosine. That's a perfect place for us to use it, right? Haha, very nice. So how about if you guys take a look right here, does this help? Ratio test wouldn't be a good idea because if you do the an plus 1 over an, I think that limit might give you 1, which you cannot draw conclusion. So now, the ratio test is helpful if we have the n in the exponent, or if you have some kind of factorial in the an part. But here, I don't think ratio test will work. So let's continue try this. Yeah, we'll step out a little bit. This is the trig identity. So in another word, we can multiply both sides by 2. So 1 minus cosine of 2 theta. This right here equals 2 times sine square of theta. So now, this right here, we have 1 over n. So imagine if we let theta equals what? I want to end up with 1 over n. So 1 over n, 2 theta. So theta should be equal to what? One over 2n. Thank you guys so much. If you let theta equals 1 over 2n, then we can nicely see that, I'll probably just write it down in blue. 1 minus cosine of 2 times 1 over 2n. This will give us 2 times sine square of 1 over 2n. And this 2 and that 2 cancel, and we get exactly what we have right here. So now let me come back here and say this is the same as the series as n goes from 1 to infinity. And just write this down, yeah? So we have 2 sine squared of 1 over 2n. Like this. Okay, now what? After we have this, now what? What's dt? I'm not sure what you mean by dt. On the divergence test, you still end up with zeros. That doesn't help. Sine of any, like, however, this is less than or equal to, but in that case, that doesn't help either because we don't have other stuff on the outside to play around with. Right, divergence test, it doesn't help because if you take the limit of this expression as n goes to infinity, we get 0, so we cannot draw conclusion. If you want to integrate this, again, we will have to think about how to integrate 2 sine square of 1 over 2x. From 1 to infinity, I don't think so. Yeah. I don't think we can compute that easily. You can handle that in proper integral by doing some other tests with that in proper integral, but we might as well just do the same thing with this infinite series. Aha, yes, we are going to compute with 1 over n squared now. And now this right here, you guys will see why it works out nicely. So, by the way, what kind of comparison? Limit comparison, yes, that's correct. Here, limit comparison test with the series as n goes from 1 to infinity of 1 over n squared. But can you guys kind of talk about it? Why 1 over n squared? Like, what make us to choose the square now? And by the way, I'm going to erase this so I have more space to do the work for you guys. Storming, you just had your Cal 2 final yesterday, and you cannot express how grateful you are to my video. Thank you so much. Thank you, and I'm happy for you too, and then hope you did well, and all the best. Alright, coming back to this series for 1 over n squared, this right here converges because the p is 2, which is greater than 1. Therefore, this right here converges. Here's a hint. Look, if you have sine to a second power, yeah, match the power. It works wonders. It works wonders. So now let's just go ahead and do it, right? So right here, I will just have to check the limit. We check the limit as n goes to infinity. Put down the one that we are trying to find out, which is 2 sine squared. But let me write it on purpose as sine of 1 over 2n, and then let me multiply by another 1 right here. Yeah, square. And I'm going to put this one on bottom as 1 over n, 1 over n. How's that? And by the way, I will just write this down. This is p equals 2, which is greater than 1, and therefore this right here converges. We are choosing 1 over n squared is because you see you have the sine squared. That's why I purposely break it down as sine times sine. And then we see the input 1 over 2n, 1 over 2n. Right here, 1 over n squared, I broke it down as 1 over n times 1 over n as well. Now, check this out. I'm going to multiply by a 2 here and a 2 here. So that means I have a 4 right here, right? Let's go ahead and multiply by 4 right here. I'm sorry, I don't have enough space, so I'm just kind of not showing all the work. Perhaps later I will do like a full detail video, but this is live stream, so I want the interaction with you guys. Aha, here have a look. Notice we have 1 over 2n, 1 over 2n, 1 over 2n, 1 over 2n. So if we let angle theta equals 1 over 2n, as n goes to infinity, 1 over 2n, which is the theta, it will go to 0. And then another note right here for you guys is the limit as theta going to 0 of sine theta over theta, this right here equals 0. I'm saying the limit as theta approaching 0 of sine theta over theta equals 0. It's equal to 0, like this. I put on 0 factorial. All right, just playing. 1. It's 0 factorial. It's 0 factorial. So, as you can see, this portion is 1. This portion is also 1. I just don't have enough space. That's why I'm just squeezing all this right here. Yeah? So, 1, 1, and then just 2 over 4, which is just 1/2. Yeah? So, altogether, this limit gives us 1 over 2, which is greater than 0 and not infinity, right? Therefore, we get to draw conclusion to this original series that this right here also what though? We're doing a comparison test. We compared this one with this, and they have the same conclusion. This right here converges, so this right here also converges. And then I will quote by the limit comparison test. And that will do it. So I'll step out a little bit. This is the work for it. Okay, any questions? Any quick questions? All right, if not, thank you guys so much for coming to today's random live stream or surprise live stream. But more important, I just want to tell you guys that thank you guys so much for the 100,000 subscribers on this channel. I really appreciate it. Thank you guys so much. And hopefully you guys all enjoyed this. This is one of my favorite series questions because it's not easy to see that you have to compare this with the series for 1 over n squared. But anyway though, you guys know it. I'll see you guys next time though. That's it. Bye.